In an earlier video, we saw that dietary oxalate intake is associated with an increased risk for cardiovascular disease, CVD-related events. Now, if you missed that video, I'm going to do a quick review because I'm going to further investigate whether my relatively high dietary oxalate intake may be neutral, bad, or good for health. So in that study, we saw that a relatively high dietary oxalate intake, in this case with a median value of 277 milligrams per day in tertile 3, was associated with an increased risk for CVD-related events. As you can see, there's a 47% increased risk, and that confidence interval 1.02 to 2.12 doesn't overlap with 1, so that's a significant association. So that's in comparison with relatively lower oxalate intakes, in this case tertile 1, which was identified as 120, with a median value of 120 milligrams of oxalate per day. Now, we then saw that this association was true for only in people that were on a low calcium diet. And a low calcium diet was identified as people who had a median calcium intake of 760 milligrams per day. So for those people, we can see the significantly increased CVD event risk for both tertile 2 and tertile 3 in terms of oxalate intake. But in contrast, oxalate intake was not associated with CVD event risk in people on medium to high calcium diets, with those values being identified as greater than 1180 milligrams of calcium per day. And as you can see, the oxalate association for oxalate with CVD event risk is now not significant after accounting for relatively higher calcium intakes, as that confidence interval, the data in parentheses for both tertile 2 and tertile 3, is not significantly different when compared with tertile 1. You can see that the data in parentheses completely overlaps 1, so it's not statistically significant. Now, we also saw in that video that just from these 3 foods, I eat a lot of spinach, beets, and carrots, my intake for oxalate is almost 1,400 milligrams per day. And I rationalized that based on this study, my relatively high oxalate intake might be okay, as calcium intake for my most recent blood test average was about 1,200 milligrams per day. And based on that amount, that would put me in tertile 3 for oxalate intake, but that would also put me on a medium calcium diet. And we can see that the confidence interval for that medium calcium with tertile 3 overlaps with 1, so it's not significant. In other words, oxalate intake is not associated with CVD event risk in people on a medium calcium diet. But is there a more specific way to evaluate whether oxalate intake may be good, bad, or neutral for health? So with that in mind, what's the correlation for dietary oxalate intake with big picture biomarkers from April 2015 through April of 2022? So I know my dietary oxalate intake over that 7-year period because I've weighed literally all my food over the past 7 years. I started tracking my daily diet in April of 2015, and I've continued it for each of the every day for the past 7 years. So I then enter those daily food amounts into Chronometer, and I'm not sponsored by them. There are many nutrition tracking apps. They're probably all relatively good. So I'm not here to say that Chronometer or any of the others are better versus, in comparison. So then Chronometer can provide or does provide daily oxalate intake, and I can log that, or I log that in my spreadsheet, and then I can then look at correlations between oxalate intake with the big picture biomarkers. So before we go there, let's take a look at my average daily oxalate intake over the past 7 years. So we're looking at a lot of red dots, and each red dot is the average oxalate intake that corresponds to a blood test. For example, in between test number 1 and test number 2 for blood test for 2022, that 49-day period prior to test number 2, so the red dot that corresponds to that is the average oxalate intake for that 49-day period. So similarly for test number 1, there was a 42-day period in between blood tests. So for that 42-day period, the red dot would be the average daily oxalate intake that corresponds to blood test number 1, and so on for each of these data points over the past 7 years. So we can see that my average oxalate intake is relatively high, almost 1,600 milligrams per day over this 7-year stretch. In contrast, tertile 3 in the previous study, the Bahaduran paper, tertile 3, the highest intake was 277 milligrams of oxalate per day, and that was the group that potentially had the highest CVD event risk. So we can see that for almost every blood test, my average daily oxalate intake is 4 to 8 times higher than tertile 3. So also note, as I mentioned, I have up to 36 blood tests for most blood biomarkers over this 7-year period. So when considering I have dietary oxalate intake for every day over the past 7 years and I have up to 36 blood tests, we can then start to address this question. So what's the correlation for oxalate intake with the big picture biomarkers over the past 7 years? So if you're not familiar what I consider to be these big picture biomarkers, If you're new to the channel, this will be new for you. So, but if you're familiar with this, I apologize. I'm just going to go through it relatively quickly. So the big picture biomarkers are a panel of blood-based biomarkers that I track regularly up to 6 to 8 times per year. And they include things like glucose, but also homocysteine. I haven't figured out where to classify that yet in the big picture biomarker scheme. But then 3 markers of kidney function, 3 markers of liver function for all the major lipoproteins, 5 immune-related cells or cell types, or actually globulins aren't a cell type, so proteins. 3 red blood cell related markers. Inflammation is indicated by high sensitivity C-reactive protein, and the overall biological age score is indicated by Levine's phenoage and aging.ai. Now, for a little bit more info, you can see a little n next to each biomarker, and that's how many blood tests that I have over the past 7 years. R at the top of the column is the correlation coefficient, and then the p-value is the measure of statistical significance or not, with a value less than 0.05 being identified as statistically significant. So with that in mind, what's the correlation for dietary oxalate with these big picture biomarkers? So first, starting from the top and working our way down, a relatively higher oxalate intake is significantly correlated with higher blood urea nitrogen, or BUN. So I've put a red arrow there, and I'm only going to go through aging data. I'm not going to go through aging and all-cause mortality data because that would be for a very long video. So for the purpose of this video, I'm only going to go through aging data. If you're interested in more info, you can just do a search for each of these biomarkers, and I've explained how it changes during aging and the association with all-cause mortality risk. So BUN levels increase during aging, as shown here for both men in green and women in blue. And you can see that it increases for men with the red line. So when considering that a higher oxalate intake is significantly correlated with higher BUN, this correlation is going in the wrong direction, so I gave it a red arrow. Now, a relatively higher oxalate intake is also significantly correlated with higher LDL. And LDL also increases during aging, as shown here for data with the men in green and women in red. And you can see that youth is characterized by relatively lower levels of LDL. And after that, it increases for both men and women. So that's why I gave it a red arrow. All right, so then a relatively higher oxalate intake is also significantly correlated with higher VLDL, also a red arrow, and that's because VLDL increases during aging, as shown here. So we're looking at data for males, as that data directly applies to me. I have a video on VLDL that goes through the data for men and women, so if you're interested in that, check it out. So starting from youth, in this case 15 and 19-year-olds, we can see that VLDL levels are around 16 milligrams per deciliter. And then during aging, up to 79 years in this study, we can see that VLDL levels approximately double. So that a higher oxalate intake is significantly correlated with higher VLDL. This is going in the wrong direction, as higher VLDL is found in aging. So that's why I gave it a red arrow. All right, a higher oxalate intake is also significantly correlated with lower lymphocytes, at least in my data, as shown there by the red arrow. And lymphocytes decline during aging, as shown here. So relatively higher levels of lymphocytes are found in youth, and then you can see by the red arrow, the red line, they decline during aging with statistical significance in the upper left corner. So when considering that a higher oxalate intake is significantly correlated with lower lymphocytes in my data, lower lymphocytes are found in the aged, not during youth. So that's why I gave that a red arrow. Now, similarly, a relatively higher oxalate intake is also significantly correlated with a lower lymphocyte percentage, with the lymphocyte percentage being lymphocytes divided by all of the white blood cells. So lymphocyte percentage also declines during aging, as shown here. So data for men in green and women in blue. And we can see a clear and consistent decline for men for the percentage of lymphocytes. Now note that that isn't only driven by a lower levels of lymphocytes during aging. We can see that also in my data, the relatively higher oxalate intake is positively correlated with neutrophils, very close to statistical significance. You can see it has a p-value of 0.06. So it's likely that higher oxalate, based on the data, it looks like higher oxalate is significantly correlated with lower lymphocytes, but also right on the verge of significance for higher neutrophils, which potentially explains the significant correlation for the lower percentage of lymphocytes. So a relatively higher oxalate intake is also significantly correlated with higher platelets, and I've given that a green line. So platelets decline during aging. So let's take a look. So in relative youth, 20 to 30-year-olds, we can see the platelets are relatively high, around 230, 231 more specifically. And then during aging, all the way up to 100 years old, we can see that platelet levels decline to less than 210. So when considering that platelet levels decline during aging, and when considering that oxalate intake is associated with higher platelets, that would be against the aging-related trend, so that's why I've given it a green arrow, not a green line, sorry. So to summarize, we've got oxalate intake, my dietary oxalate intake, and it may be different for others, but this is what my data shows, is significantly correlated with 5 biomarkers going in the right direction, in the wrong direction, and only 1 platelets going in the right direction. So with that, we have a net score of -4, and that suggests that reducing my oxalate intake below my average, my 7-year average of about 1,600 milligrams per day, may be better for overall systemic health. Now note that, as I mentioned on the opening slide, that relatively higher calcium intakes impact the association for oxalate intake with CVD event risk. So what about this question? Does dietary calcium intake affect correlations for oxalate with the big picture biomarkers? So I then looked at that, and there's the data there with the correlation coefficient and a p-value for the oxalate divided by calcium ratio and its correlation with the big picture biomarkers. So after accounting for calcium intake, more specifically this ratio, correlations for blood urea nitrogen, for LDL and VLDL, and for lymphocytes and the lymphocyte percentage are no longer statistically significant. So that's potentially good news, because that suggests that having a relatively higher calcium intake may indeed affect how oxalate being associated with big picture biomarkers, as statistical significance goes away for all 5 of the red arrows that were only correlated with oxalate intake. But platelets are still going in the right direction, so we've got 1 green, and we've removed the data indicates the removal of 5 red arrows. But we've got new significant correlations that pop up. Higher oxalate to calcium ratio is now significantly correlated with higher uric acid, as shown there, and uric acid levels increase during aging. This is data for men. So in this study, it was a longitudinal study for men starting at different ages. So whether looking at 20-year-olds longitudinally, 30, 40, 50, or 60-year-olds, uric acid levels increased for each respective age group. So that's why I've given that a red arrow, because higher oxalate to calcium ratio, higher uric acid is found in older relative to younger people. So a higher oxalate to calcium ratio is also significantly correlated with higher levels of alkaline phosphatase. Now, whether alkaline phosphatase increases during aging is debatable. There are a couple of studies that show that it does increase, but also a couple that showed no increase. But more definitive is that relatively higher levels of alkaline phosphatase are associated with an increased all-cause mortality, ACM risk. And that's what's shown here. So this is a study of almost 9 million people. And when the confidence interval, so the dashed lines, when they are both completely above a hazard ratio of 1, as delineated by that red line, then we have statistical significance. So that becomes true at an alkaline phosphatase level of 48, above which the association for alkaline phosphatase with an increased all-cause mortality risk becomes evident. So higher levels of alkaline phosphatase above 48, significantly associated with an increased all-cause mortality risk. So when considering a positive association for the oxalate to calcium ratio with alkaline phosphatase, this is going in the wrong direction based on all-cause mortality risk data. And then we also have a positive correlation, so a higher oxalate to calcium ratio is significantly associated with a higher red blood cell distribution width, or RDW. And that's potentially a problem because the RDW increases during aging, as shown here, and you can see the trend line for RDW and how it changes during age. So that's I've given that a red arrow because higher RDW found in aged relative to youth. So to summarize the oxalate calcium ratio and associations with or correlations with big picture biomarkers, we've now got only three biomarkers going in the wrong direction, but 1 going in the right, with a net score of -2. So after accounting for calcium intake, dietary oxalate is still significantly correlated with more biomarkers going in the wrong direction than right. So with that in mind, going forward, I'm going to replace spinach, where I'm getting about half of my daily oxalate intake, with other low oxalate greens, in this case collard greens, as I prefer the taste of that over other greens like kale and others. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon. Thanks for watching. I hope that you enjoyed the video. Have a great day.